Now, let us discuss kinematic indeterminacy. Till now, we have studied static indeterminacy and how to calculate a static indeterminacy for various types of elements. That may be a beam or a frame or a truss. Now, kinematic indeterminacy is quite opposite to that of a static indeterminacy. In static indeterminacy, we are bothered about the reactions which are offered by the supports. But now here, we are bothered about what are the freedoms left over after offering reactions. For example, if I take a roller support, this is going to offer a vertical reaction. That means it is not going to move in vertical direction. It has lost its freedom. So this roller support has some more freedoms left over. What are those freedoms? If I apply a horizontal load, this roller support is going to move horizontally. That means this has freedom. Right, students? This has freedom to move. And one more thing, if I apply a moment, it will tend to rotate. It will not resist. That means it is also having degree of freedom. I am mentioning here the word degree of freedom. And it may be a plural, a degrees of freedom. Coming to this roller support, we are having 2 degrees of freedom. Right, students? So 2 degrees of freedom. And how did we calculate that this has 2 degrees of freedom? Actually, 1 degree of freedom is lost and remaining 2 degrees of freedom are left over in this support. How to calculate for other supports, and I will make the things very simple. Believe me, students. Right. Coming to the basics. If I take a a rigid joint. A rigid joint will have total 6 degrees of freedom. 6 degrees of freedom. What are those? You might observe in this figure that in X direction, Y direction and Z direction displacements, and X direction, Y direction and Z direction rotations. So total 6 degrees of freedom for a rigid joint. Okay, students, coming to a plane, a rigid joint. Plane means in 2 dimension. In 2 dimension, a rigid joint will have 3 degrees of freedom. See this in figure. You might be observing in X direction, Y direction displacements and in Z direction, and in this plane, XY plane, rotation. Right? So there will be 3 degrees of freedom. Okay. Coming to a truss joint or a pin joint. Right. In pin joint, we are least bothered about the rotations. Student, please follow me. Here, you might be observing the difference between space rigid and space truss. In rigid, we are considering the rotations. In truss, we are not going to consider the rotations. We are just considering the displacements. So here we will be having only 3 degrees of freedom. Right, students? Coming to plane truss joint. In 2 dimension, a truss joint will have only 2 degrees of freedom. As rotation is eliminated, compare this. As rotation is eliminated, we will be having only 2 degrees of freedom. That is horizontal and vertical displacements. Right, students? Coming to the supports now, you will be clearly able to calculate what are the degrees of freedom left over at this support. Just think of this hinge support is going to offer 2 reactions. Under what category this hinge falls? Is it a space rigid, plane rigid, space truss or plane truss? Just be clear. As this is a support and we are going to use it in beams or whatever maybe frames. So considering this as a plane rigid joint, this will be having 3 reactions. Generally this will be having 3 reactions or 3 degrees of freedom. But here we are going to lose 2 degrees of freedom. 2 degrees of freedom are lost. We are having 3 degrees of freedom. In that, 2 degrees of freedom are lost. So, finally we are left out with only 1 degree of freedom. 1 degree of freedom. Understand, students? Alright. Coming to the fixed support. At the fixed support, we are having 3 reactions, which I have already mentioned in calculating static indeterminacy clearly, that the fixed joint will be having 3 reactions. Right, student? So, in this category, this is going to be a plain rigid joint, and totally 3 degrees of freedom are lost, just like a married person. Right, students? Understand? So, in these 3 reactions, 3 degrees of freedom are lost, totally degrees of freedom are 0. Right, students? Coming to a free, I am considering this free end. Coming to this free end, we will be having total 3 degrees of freedom, as there are no reactions. This is a bachelor. Think of, students. Bachelor will be having different types of freedom, right? This is having 3 degrees of freedom. No freedom is lost. Okay, students? This is the basic thing which we are going to use to calculate kinematic indeterminacy. Once it is clear, kinematic indeterminacy is very, very, very simple. Understand, students? So, be perfect in knowing these things. And if you are not able to catch this point, just go back and watch this once again. Okay, students? Right. Let me solve some simple examples using these basics. Then you will be getting clarified. Okay? Consider this. What do you call this? Already I have drawn this in static indeterminacy, and you will be calling this beam as a proper cantilever, right? Okay. In this element, how many joints are there? 1, 2. Right, students? It is very, very clear that there are 2 joints. And in which category will they fall? In beams and frames. Simply, we are going to deal with 2 dimension. This is a 2-dimensional or a plain rigid joint. In this category, we will be having 3 degrees of freedoms. Right? 2 joints are there. Each joint will have 3 degrees of freedom. So totally 6 degrees of freedom. We should have 6 degrees of freedom. But we have lost some degrees of freedom, as this support offers reaction. This support offers reactions. How many reactions this support is going to offer? 3 reactions. And what about this? Right, students, 2. Total 5 reactions are offered from these supports. So we have lost our freedom, 5 degrees of freedom. So we are left out with only 1 degree of freedom. Only 1 degree of freedom. I call it as kinematic indeterminacy. Here comes our title. You keenly observe this. This is called kinematic indeterminacy. Right? So, I can define the kinematic indeterminacy as degrees of freedom which are left over after the offering of reactions. Understand, students? Let us solve some more examples. You just please try it out. You try it out this. Yes, this is a hinge. Okay. At hinge we are going to have 2 reactions. Roller 1 and this is a hinge 2. Okay, students? Right. How many joints are there? 3 joints. Each joint will have 3 degrees of freedom. So total there should be 9 degrees of freedom. In that 9 degrees of freedom, we have lost 5 degrees of freedom. 2 plus 2 plus 1. So, we are left out with only 4 degrees of freedom. That is kinematic indeterminacy of this beam. Understand, students? Right. Follow with me. Some more examples. You just try it out. What do we call this as? As I already mentioned this as internal hinge. In calculating static indeterminacy, I have posed the same question. Right. Here we need to calculate kinematic indeterminacy. Right. So, don't bother about this internal hinge. When it comes into this picture, just remind in mind that some addition is going to happen. Right. In static indeterminacy, what we have done is, if this internal hinge comes, we are going to add an extra equilibrium condition. Right, students? Here we are going to do the similar thing, but in another way. Right. Consider these as joints. Don't read this. Consider these as joints. So there are totally 2 joints. Each joint will have 3 degrees of freedom. So 6 degrees of freedom. Okay. Here at fixed end, we are going to lose 3 degrees of freedom. At hinged end, we are going to lose 2 degrees of freedom. So totally we lost 5 degrees of freedom. We left out with 1 degree of freedom. What about this internal hinge? As this internal hinge offers 4 additional degrees of freedom. Please remain in mind, be alert, and remind that if an internal hinge occurs joining 2 members, please remind, joining 2 members, 4 degrees of additional freedom will be added. Okay, right. Let me add this. So, total degrees of freedom is 5. Right, students? I want to tell you one more thing. In this, particularly in this topic, kinematic indeterminacy, we might be observing that in question paper, neglecting axial strain. Be careful if in that question it has given that neglecting axial strains or neglecting axial deformations. Please do one thing. After calculating kinematic indeterminacy, please remove the number of members. In this case, what is the kinematic indeterminacy after neglecting axial strain? Basically, I have calculated kinematic indeterminacy in this way. Right. It is 1. How many members are there? Member is nothing but joint to joint. There is 1 member. So, kinematic indeterminacy after neglecting axial strain becomes 0. Please keenly observe one thing. If it is given in question like this, neglecting axial strain, do the calculation as usual and remove the number of members. Understand, students? Please follow with me and calculate kinematic indeterminacy neglecting axial strain for this member. Right, you can do easily. This is 4. Already I have calculated. Right, 4. How many members are there? 1 and 2. So, kinematic indeterminacy neglecting axial strain is 2. Right. Coming to here. What is kinematic indeterminacy neglecting axial strain? So, here are 2 members. This is also a node or a joint. So, 5, 1 and 2 members. Right, students? Hope you are clear with this. How to calculate kinematic indeterminacy by neglecting axial strains and considering axial strains. Clear, students? Let me do some more problems regarding frames.